So today we are going to see about the operation of TRIAC and DIAC. So both are the bidirectional devices. So TRIAC is a controlled bidirectional device and DIAC is an uncontrolled bidirectional device. Bidirectional device in the sense they are having both current carrying capability of both the directions. So TRIAC is an anti-parallel connection of two ACRs. So since ACR is a unidirectional device, if we are connecting two ACRs in anti-parallel, so the construction is same as that of a TRIAC. And DIAC is an anti-parallel connection of two diodes. Since a diode is also a unidirectional device that can carry current in one direction, but the DIAC is capable of carrying current in both the directions. So both are the bidirectional current carrying devices. So first we can see the TRIAC introduction. So the SCR can conduct current in only one direction, and in an AC system we have to control the voltage as well as the current flow has to be in both the directions. So the SCR cannot conduct or cannot control the voltage in both the positive half cycle and negative half cycle. So we can use the TRIAC for the control of voltage in both the positive and negative half cycles. And TRIAC is a name implies it is a triode AC switch, and it is a three-terminal device, and its formal name is bidirectional triode thyristor or bilateral triode thyristor. And a thyristor is an analogous to a relay in that a small voltage and current can control a much larger voltage and current. Here the terminals are main terminal 1, main terminal 2 and the gate. And TRIACs bidirectionality makes them convenient switches for AC current, and this is commonly used in the controlling the speed of induction motors, dimming lamps and controlling electric heaters. So these are the bidirectional devices. So and also it is a medium power application device. So this is the first one is the waveform of the controlled output waveform and input waveform of the TRIAC, and second one is the symbol of the TRIAC. So here both the positive half cycle and the negative half cycle of the voltages are controlled. So what are the differences between SCR and TRIAC means? So SCR is a unidirectional device, so it can conduct only in one direction, that is from anode to cathode only. It will allow the current in reverse direction, the current flow is not allowed. And the gate current can be only positive. The positive gate voltage will be applied across the gate source, gate and the cathode. And the SCR can operate only in one quadrant of VA characteristics, that is the first quadrant. And TRIAC is a bidirectional device. It can conduct current in both the directions, that is the positive half cycle and also for the negative half cycle. The gate current can be positive or negative. We can apply both the positive voltage or negative voltage, and it can operate in both the quadrants, that is first and third quadrant it can be operated. And this is the waveform representation for the conduction of SCR and TRIAC. The first one is the input voltage, so it is a AC voltage, and the second one is the gate voltage. So we are applying the gate voltage at the gate trigger level represents the gate triggering instance at which the gate pulse is applied, and the TRIAC will start the conduction after the application of the gate pulse. So the conduction is starting from the instant of gate triggering pulse applying point. So the SCR we can see, so it will conduct only for the positive half cycle, and negative half cycle it is in reverse bias, so that it will not conduct in the negative half cycle. And in the second waveform we can see the output voltage of the TRIAC, so it will conduct in both the positive half cycle and the negative half cycle, and it is since it is a bidirectional device. So TRIAC is a 3-terminal 5-layer semiconductor device. Earlier we have seen the SCR as 4-layer device. Here it is a 5-layer device, and forward and reverse characteristics are identical to the forward characteristics of SCR. So as we already mentioned, it is a anti-parallel connection of SCR. So the characteristics of the TRIAC are same for the SCR and TRIAC, and only the difference is it will operate in first quadrant and also in the third quadrant. as forward and reverse. And the three terminals are here, also already mentioned, MT1, MT2 gate. A triac is an equivalent to two separate LCRs connected in anti-parallel or inverse parallel. That is, anode of each is connected to the cathode of the other, and with the gates common. And it acts like a bidirectional switch. It can conduct in either direction, and it consists of two parallel diodes connected in opposite directions with a single gate lead. The gate provides control over conduction in either direction. So here it is a basic structure, and it is a electrical equivalent circuit, and the two SCR will have the layers of P1N1, P2N2, and another one SCR will have the layers of P2N1, P1N4. And this is another representation of the TRIAC. So we can go for the operation. So this is the construction of the SCR. So it is a 5-layer device. So the MT2 is connected between the layers P1 and N4, and the MT1 is connected between the layers N2 and P2, and the gate terminal is connected between the layers P2 and N3. So here we can have 4 modes of operation. That is, here MT1 is the reference terminal for the gate as well as MT2. So for the first mode of operation, the MT2 is positive, and the gate will also be positive with respect to MT1. And the second mode is MT2 positive and gate negative. And third one is MT2 negative and the gate positive. And fourth one, both they will be negative. MT2 as well as gate will be negative. So this is the 4 modes of operation. So first one, MT2 positive, gate positive. Second one, MT2 positive, gate negative. Third one, MT2 negative, gate positive. And fourth one, MT2 negative and gate also negative. So this is the first mode of operation, that is MT2 positive and gate is also positive. So here we can see the layers P1, N1, P2, N2. So for this mode of operation, the P1, N1 is forward biased junction, and also P2, N2 is also a forward biased junction. The in between junction, that is P2, N1. So sorry, it is a typographical mistake. That is a P2, N1 is reverse biased, and if gate is applied, the gate current will flows from the P2 layer to the N2 layer, so that it will inject positive charges from towards the P2 layer, so that will break down the P2 N1 junction. So after that it will conduct as an SCR, and it is conducting in first quadrant, and it is more sensitive in this quadrant. And the second mode of operation is MT2 positive with a gate negative with respect to MT1. So here also the P1 N1 junction is P1 N1 and P2 N2 are forward biased, and the in between junction N1 P2 is reverse biased. Here the gate current is applied as negative. So first one, the gate current will flows from the positive terminal to the, or it will inject the charges, or the current will flows from the P2 to N3. So for this condition, initially the current conduction starts in the layers P1, N1, P2, N3, so that it is called initial conduction of SCR, that is, it is called as pilot SCR. And if the conduction is started in these layers, that is P1, N1, P2, N3, the two regions are formed. First one is the left side region of P2 and the right side region of P2. In the right side region of P2, the potential will falls, and it is connected to the MT2, that is positive, that is a left hand side region is having the potential of positive, and the right hand side region of P2 is connected to MT1, that is negative. So at this condition it will have potential gradient between the left side region and the right side region. Due to this a potential gradient, the current will flows from the left side region, that is positive, to negative, that is a right side region. So under this condition, the current will flows from the left to the right side region. So after this, the conduction will starts or will conduct will be initiated in the P1 N1 P2 N2, and finally the SCR will conduct as P1 N1 P2 N2, that is the main SCR. So the anode current of the pilot SCR will serves as the gate current of the main SCR. So here also it is connected in first quadrant, that is it is in a less sensitive operation. Then third mode is MT2 negative but gate positive with respect to MT1. So here P1 N4 and P2 N1 are forward biased, but the junction P1 N1 is reverse biased. So the gate positive. So the junction P2 N2 is forward biased, and here the junction P1 N1 breakdown, and after this the conduction layers are P2 N1 and P1 N4, and here it is a third quadrant of operation and it is less sensitive. And it is a fourth quadrant, both the gate and MT2 are negative with respect to MT1. So here the outer junctions P1 N4, P2 N1 are forward biased, N1 P1 is reverse biased. So when gate is applied, the P1 N1 breakdown, and finally the conduction will start from P1 P2 N1 and P1 N4, and it is also a more sensitive in the third quadrant of operation. And this is the characteristics. If you are increasing the gate current, the breakdown voltage will be reduced. So first one, the MT2 positive, it will conduct in the first quadrant, and if MT2 is negative, it will conduct in the third quadrant with the gate current also negative in the third quadrant. And these are the advantages and disadvantages of TRIAC. And the next one is the diode, that is a diode AC switch. It has two electrodes. It is a member of the thyristor family, and it is mainly used in triggering of thyristor. It can be turned on either simply by reducing the voltage below its avalanche breakdown voltage. Also it can be either turned on or turned off by for both the polarity of voltages. This device works when an avalanche breakdown occurs. The DIAC is basically a two-terminal parallel inverse combination of semiconductor layers that permits triggering in either direction. So there is no control terminal in this device. It is an uncontrolled device. Physically it looks like a regular semiconductor diodes connected in anti-parallel. So this is the symbol and the construction. So it is similar to the two diodes connected in reverse or in anti-parallel. And this is the characteristics. If we increase the anode to cathode voltage, it will beyond the breaker voltage, it will start the conduction, and similarly it will conduct for the reverse.